Hi everyone, in this short video I'm going to have a bit of a talk about the real number system. Now let's start with the natural numbers. So the natural numbers, there's no 100% agreed system, but so traditionally, the natural numbers are the set of numbers that start with 1 and then 2 and 3 and so on and so on. So they're sometimes also referred to as the counting numbers. It's the first sets of numbers you learn when you're a small child because we count things and it's very natural to start counting at 1. Some people think that the natural numbers should include 0, but oh well, that's just a matter of discussion. Some people will say that. Now the integers, there is a lot more agreement here on the integers. The integers are symbolized by the letter Z, and the integers, they include the negative numbers like -3, -2, -1, 0, very important. Then the naturals, 1, 2, 3, and so on. So the integers are an extension of the number system, but they still don't include, they still jump. They jump in unit size steps. And if you were to look at the number line, the integers would be all the little marks on the number line, but there would be nothing in between the marks. And for that one, we start talking about the rational numbers. Now, rational in terms of ratio. Just let me highlight the word ratio here as part of this word. Ratio, obviously, sounds like fraction, doesn't it? Or a quotient. Now we give this letter Q. Now the rational numbers, I won't do the proper definition. I'll just put some examples. The rational numbers could be any integer divided by another integer. So just think about that for a minute. We're building up from what we previously had. Pick any integer you like, for instance, -3, divide by another integer as long as it isn't 0. So we could divide by 2. That's a rational number. You might also refer to that as -1.5. Another example would be, say, 1 divided by 3. That's one integer divided by another integer. Get rid of that little warning in the corner there. Now, of course, we could have something, crazy like 4 divided by 6. Now, that's still a rational number, but we, of course, would realize that that could equally be expressed as 2 over 3. Usually with these rational numbers, we express them where there is no common factor. But 4 over 6 is a rational number. It just happens to be the same as 2 over 3. You can see some of them are negatives, some of them are positives, etc., etc. Now, I couldn't possibly list them all. That wouldn't be. Now, a couple of things about these rational numbers. Things like, 3 over 2. Well, that would be represented as the decimal 1.5, the decimal stops. Numbers like 2 over 3, that would be represented by the decimal 666. And the sixes keep going, so we put a little dot there. That's a feature of rational numbers. The decimal representations either terminate or have a repeating pattern. We could have a rational number. I won't try to write a fraction for this one. There could be a rational number which goes decimal 1, 4, 1, 4, and the 1 and the 4 are a repeating unit. That's a rational number as well. So these rational numbers, ratios, allow us to fill the gaps on the number line in between the integers. And for a long time, that's what people thought, that every number, the ancient Greeks, the Pythagoreans, thought that the rationals were going to fill all the gaps on the number line, but they were wrong. There are extra numbers. So there are irrational numbers, numbers which are not rational. Now, the irrational numbers are things like pi. So pi is, I should have said approximately, 3.1415, and off it goes. No repeating pattern, no terminating decimal. That's what makes an irrational number. The decimal expansion does not repeat and it does not terminate. There's also numbers like the square root of 2. So that's something like, I think, 1.41 and goes off again, the decimals go forever with no repeating pattern and not terminating. These are the irrational numbers. So the irrational numbers are, are in the gaps on the number line, but they're in the gaps in between the rational numbers, if that kind of makes sense. So the real number system, the real numbers, is, well, it's really a combination of two sets. It's the rationals and joined to the irrationals. So together, the real numbers include all of the spots on the number line that you could think of. Every single point on the number line would be covered by the real numbers. And that's the end of my little story for today. Oh, actually not quite. I just thought of one extra thing. One extra thing. Where would a number like square root of 36 belong? Well, square root of 36, it looks like it could be irrational because there's a square root sign, but of course it's a perfect square number. It's actually the number 6, isn't it? So it could be, you could put it into the set of rational numbers as 6 over 1. Okay, that's the end of that for today. Thanks for watching.